further math, we're going to look at question 1819 from exercise 10A, which is a revision chapter for financial. So question 18, we know Peter borrows $80,000 for 10 years at a 5.6% per annum interest rate, compounding monthly, okay, with monthly repayments of 555. Which one of the following statements is true? Okay, so let's check out whether the loan will be fully paid out in 10 years. So we've got to check out each of the options. And this is actually a good question because it forces us to check whether we understand the problem. So if I've got an interest rate of 5.6%, my principal is 80,000, my PMT is negative 555 because we're making repayments of 555 per month. My final value would be 0, 1212 because it's monthly. My the months I need to take to pay out the loan is 239 months. So 239.87, 239.87. You can do this on your scientific calculator. If I divide that by 12, that's actually 19 years. Okay, 19 years, a bit more than 19 years. Okay, so that's bogus. We're not going to pay out the loan in 10 years because it clearly says 19.9 something years. Okay, so at the end of the 5th year, the balance of the loan will be 40,000. So let's check if that's true. So if I were to change the n to 5 times 12, at the end of 5 years, let's see what the balance is. That's bogus as well because my balance is not 40,000, it's actually 67,000 something. Okay. The amount of interest each month during the loan increases. That doesn't make sense because what's happening with the loan balance each month? You're paying the loan back, so it's amortizing. So what's happening is, remember, you get charged a percentage of interest on whatever you owe. Whatever you owe is decreasing every month, so your interest will be decreasing. So it's not going to increase. So that's not correct. Now D, the weekly payments of 132 compounding weekly will reduce the loan, reduce the period of the loan. Okay, so let's go back to our first part because we know we need 239.87 months to complete the loan. Okay, let's see if weekly changes things. So weekly means, well, we'll ignore that for now. Let's see, because we need to find how many weeks it would take out to pay the loan. It's 5.6% per annum, $80,000. Each week we're going to pay 132, and you've got to make sure the final value we want to be 0. Weekly means 52.52. Oops, 52.52. I want to check what my weekly is. So my weekly is 952.50. If I divide that by 52, I can get like the equivalent amount of years it takes to pay the loan. 18.89. What do we have before? 19.989. Okay, so clearly 18.89 is shorter than 19.9 something. So D works out to be the correct answer. If one extra payment of 2,000 is to be made, it will make it. It will be better to make it at the end of year 8 than at the end of year 2. Okay, if an extra payment of 2,000 is made, it will be better. It would be better to make it at the end of year 8. Okay, that doesn't make sense. The earlier you doesn't make sense because the earlier you pay off, the loan, or add extra payments to the loan at the start, it's better because you get charged interest less later down the track. So that's bogus. So D's the correct answer. So it was a tricky question. This could well have been like one of the later questions in the financial chapter to check whether you really understand the topic. So question 19, $15,000 is invested for 12 months. The first 6 months, the interest rate is 6.1% per annum compounding monthly, and after 6 months, interest rate increases by 6.25% compounding monthly. The total interest earned is closest to. So really simple. This is a compound interest problem. Okay, so it's not we're not adding payments or anything like that. $15,000. What's happening is you earn a certain amount of interest, and then what's happening is that it increases again. So all you need to do to calculate total interest is your final value, whatever that is, minus your principal. Okay, so you're going to have to do this like a financial change question, but it's just a simple compound interest. So you're not adding any payments. So first part is we know that $15,000 invested. So I'm giving the bank money, $15,000. Oops, $15,000. The first 12 months, 12. Oh no, first 6 months. Sorry, read the question carefully. It says first 6 months, it's got an interest rate of 6.1%. The payment is zero because we just put the 15,000 in straight away and then not doing anything. We're just waiting for it to grow. My final value we need to work out 1212 because it's monthly. My final value is this. Okay. Now after 6 months, there's a financial change. I'm now investing the money again, and it's 6.25%. So I'm going to put this at the top. I'm investing, so it's negative. I'm changing my interest rate to 6.25. My N is still 6 because we're just investing another 6 months. And I want to work out my final value. Okay, my final value is 15952.91. Now, this is the amount I get at the end. So if I look at back at the graph, this is my final value. So to get the interest earned is the difference between my final value and my initial value, which is 15,000. So if I subtract 15,000 from that, I should get 952.91. 952.91, which is 953. So D is your correct answer. Okay, so you can do compound interest problems or financial change compound interest problems on the financial solver. So hopefully that helps.